good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. In the previous classes, we have been discussing about the concept of machines, and today we will be having the last class on the machines. Okay, so the numerical problems on the chapter machines has been already uploaded in our channel. You can see those videos, and if you have any doubt, any query, you can obviously ask in the comment section. So in the last class we have discussed about pulley, isn't it? And we have also talked about the various types of pulleys, that is a single fixed pulley and the single movable pulley. Today we will be going to discuss about the combination of pulleys. Now you might be wondering why we need to combine pulley. In order to answer this question, can you think of that what is the mechanical advantage of single fixed pulley? I think if you have watched the previous video, then you can easily answer the question. If you have not watched the previous video, please go to the previous video, watch the entire video. The concept of pulley, I think, will be clear to you. Okay, so if you have remembered, the mechanical advantage of single fixed pulley is 1, isn't it? Mechanical advantage of single fixed pulley, MA of single fixed pulley is 1. So a single fixed pulley neither acts as a speed multiplier nor acts as a force multiplier. So what does it do? It simply changes the direction of the application of force to a more convenient direction, isn't it? We have discussed this. Okay. And what is the mechanical advantage of single movable pulley? Single movable pulley, if you remember, the mechanical advantage of single movable pulley is 2, isn't it? Single movable pulley, it's 2. So single movable pulley, the mechanical advantage is 2. So with this kind of pulley, you can at the maximum apply a effort which is half that of the load, not less than that. So if you are lifting a load of say 500 Newton, you have to at least apply a load of 250 Newton in order to lift that load. Okay. So what happens if the load is quite greater than this? Say if the load is of 5000 Newton, isn't it? It can be in the industries we have big loads. So in those cases, we are in need of a combination where we can have a mechanical advantage greater than 2, so that we can apply a very less effort and lift a heavy load. Okay, so for that kind of pulley system where we need to have mechanical advantage greater than 1, we need to combine the pulleys. So what we do, we need to combine the pulleys. So here comes the concept of combination of pulleys. Okay, so when we say of combination of pulleys, there are two kinds of combinations. So what are the combinations? First of all, we can use a number of movable pulleys, with a single fixed pulley. Movable pulleys with a single fixed pulley. Okay, and what is the second combination? Second combination is the block and tackle system. So this is the second combination, block and tackle system. Okay, so this is the second combination. So these are the two combinations or arrangements where we can get the mechanical advantage greater than 2. Okay, fine. So this number of when I say that a number of movable pulleys are used, the movable pulley is obviously more than 1. We have seen the combination where one movable pulley and one fixed pulley is used, and we have seen that in that case the mechanical advantage is at the max 2, not greater than that. So if we use a combination of more than one movable pulley with a single fixed pulley, then we will get some mechanical advantage which is greater than 2. Okay. So now let us quickly move on to the arrangement. First arrangement where we use a single fixed pulley with a number of movable pulleys. Okay, so let us check out what will be the mechanical advantage of this kind of combination. Okay, so coming to the first arrangement, If you have any doubt regarding the theories that we have been discussing in these videos, please do mention it in the comment section. We will be always happy to solve your problems and queries. Okay. So coming on to the first arrangement, we are using a single fixed pulley with a number of movable pulleys. So number of movable pulleys used with a single fixed pulley. Number of movable pulley with a single fixed pulley. Okay. So what will be the arrangement? What will be the combination be like? Say if you consider that we are using 3 movable pulleys with a single fixed pulley. If the number can be greater than 3 also. For the time being, let us just consider that we are using 3 movable pulleys with a single fixed pulley. So what will be the diagram? Okay, so if I consider the diagram, so here, so there is a rooftop or ceiling. From here, a single fixed pulley is used. Okay, single fixed pulley is used. This single fixed pulley is tightly attached to the supporting center. Okay, then here we have one movable pulley. Okay, so here we have one movable pulley. The movable pulley, okay, the end of this, first let me draw the diagram, then I will be explaining the concept. Okay, fine. Okay, with this, then again there is another movable pulley here. Another string will be passing through this point. Okay, so it will be attached to this particular hook. Okay, and there will be another in combination. So let us take another combination. The load will be attached to the last of the pulleys. Okay, so from here, okay, so this is the possible combination. Okay, now say the load will be attached to this last pulley. So this is the load. The load L obviously acts in the downward direction, isn't it? I think the view is clear. Okay, fine. So this is the figure for a single fixed pulley used in combination with the number of movable pulleys. The tensions, as you can clearly see from the figure, the tensions will be something like this. So let us consider this T1. See, you have 3 different strings here, 1, 2 and 3. So the tensions in the 3 different strings will also be different. So we are naming them as T1, T2 and T3. Okay, here the effort is being applied and here is another tension T3 balancing it. Okay, so this is the combination. Now in this case, so I think the diagram is clear. Please note the diagram properly, as because the diagram very often comes in the examination. So please note the diagram, it will be helpful for you. So here, if we do some algebraic manipulations, then you can easily get that the load is being supported by the different tensions, and if we do mathematical calculations, we will see that the load, the value of the load is coming out to be something combination of all these tensions. Okay, and if we finally put the values of load and effort in the formula for mechanical advantage, or say velocity ratio, then the velocity ratio will come out to be 2 2 to the power n. Okay, 2 to the power n. And if we consider the ideal pulley system, then the mechanical advantage also comes out to be 2 to the power n. So if you have, so for this particular figure, if you have 3 movable pulleys, okay, first just let me point out that this n denotes the number of movable pulleys. N, not the total number of pulleys, only number of movable pulleys. So in this figure you have how many movable pulleys do you have? 3. So obviously the mechanical advantage or the velocity ratio for this arrangement will be 2 to the power 3, that is equal to 8. So for this kind of arrangement, the mechanical advantage comes out to be 8 and the velocity ratio also to 8. So for this, if we consider the ideal system, then MA is equal to VR is equal to 2 to the power 3, that turns out to be 8. So you have to apply an effort which is 1 by 8 times the total load. So it becomes much easier to pull up a load using this kind of arrangement. Okay, so I think the concept is clear. Fine. Okay, so this is the idea. Now let us quickly move on to the second arrangement. We have said about block and tackle system. You have not drawn the diagram or not understood the diagram, please just rewind that little bit. I think the diagram will be clear to you. Okay, so now let us quickly come on to the second arrangement, that is the block and tackle system. For block and tackle system, we have basically 2 arrangements. One case where we will be having an even number of pulleys, and the other case is where we will be having odd number of pulleys. So let us consider the block and tackle system. Okay, block and tackle system. So how does the block and tackle system act? Fine. So next arrangement is our block and tackle system. So block and tackle system. So as I said that block and tackle system will have 2 different combinations. One is where you have odd number of pulleys and one is where you have even number of pulleys. Okay. See, first of all let us consider the case where there are even number of pulleys. So if I consider that there are 4 pulleys, okay, so it will be something like this. If you have even number of pulleys, then the upper and lower block will both have equal number of pulleys. Remember this thing. Upper and lower block will have equal number of pulleys. Fine. So just let us draw 4 pulleys first of all. 1. Let us draw it a bit small so that it will be easy to accommodate on the board. 1. Then comes the second pulley. Here comes the third pulley. I think, are you able to see it? Okay, just a little bit, a little more smaller, and this is the fourth pulley. So I think you are able to see it. Just let me bend down the camera a little bit, so I think it will be easier for you to see. Okay, so this is the fourth pulley. Okay, fourth pulley. Fine. Now the upper block is fixed to this point. The upper block is fixed to this point. Okay, the upper block is fixed to this point. There is one, and this is a lower block. Okay, this is the lower block. Fine. Now in this case, or in this kind of combination, there will be only one single string. So you need not to worry, there will be one single string and the tension will be same flow. So for this kind of combination, what will be the arrangement of the string? Let us see. Okay, so for this kind of arrangement, remember the string will start from the upper block. I think the figure is clear. The string will start from the upper block. Okay, and down it goes like this. Okay, so just I think you can have a clear vision. The string is starting from the upper block. Okay, fine. Now and the load will be supported at the lower end. So here comes the load. So I think you can view the load. Okay, fine. So here comes the load. The load will always be acting in the downward direction. Okay. So for this, what will be the tensions? What will be tension acting? One tension will be acting at this point, tension T, at this point, tension T, again at this point, tension T, and this point, tension T, and here will be the tension T, here will be the effort E. So this is the combination. So I think that the diagram is clear. The diagram is very important from the perspective of the examinations, as well as if you consider the concepts. The diagram is very important. The second combination, as I was talking, we will have odd number of pulleys, and in case we have odd number of pulleys, remember the upper block will have one more pulley than the lower block. The upper block will have one more pulley than the lower block. Remember this thing. The upper block will have one more pulley than the lower block. So it will be something like this. Okay. So these are the three pulleys. The upper block will have one more pulley than the lower block. So remember this particular combination. Okay. So if I consider the upper block, it is fixed here. The upper block is fixed. Okay. The lower block is hanging. It will be something like this, and the load is supported here. So here the string, here the string actually starts from the lower block. Okay. So from this point, the string will start and it will roll down like this, then it will roll down like this, then it will roll down like this. So this is the combination. Okay. So I think it is clear. So this is the combination, and if I consider the tensions or the load will be definitely yes, it will be attached to this point. So this is the load acting in the downward direction. The tensions, as you can see, is being, so here is one tension T as the pulley is pulling it down. Here will be one tension T, here will be one tension T, and here will be one tension T, with the effort being applied here. Okay. So this will be the combination. So it is clear. And for these cases, the velocity ratio as well as the mechanical advantage will be equal to n. That is the total number of pulleys. Okay. So today we will be ending our class here. Okay. So thank you. Please go through the video once again to make your concepts clear. We will be meeting in the next class. Till then, please take care and goodbye.